Okay, I'm going to look at some double integrals. In particular, I'd like to illustrate the process of passing between the region of integration and the limits on the double integral. So here we're given a double integral and we're told the shape of the region. The region is the triangle with vertices 0, 0, 0, 1 and 2, 1. And what we've got to do is integrate the function x squared plus 5y squared x over that region. Now, at the moment, the integral's just got the label r, saying the name of the region over which we are to integrate. To actually calculate this, we need to put limits on the integral. So let's see how to do this. And the first thing we have to do is to draw a picture of the region. So let's do that to begin with. I'll give this integral a name as well. Let's call this I. So naturally, I draw in these vertices. There's 0, 0, 0, 1. That's 1 up, and 2, 1. So that's 2 along, and 1 up. So now I know what triangle this is that we're looking at. So there's the region of integration. Now, how do I get from this region to limits on the integral? Well, let's do it down here. Now, I'll try it the way round as given, dx dy rather than dy dx, though maybe I would switch the order if it looked too difficult the first way round. Now, it actually doesn't really matter what the integrand is for what I want to do here. I'm not actually going to bother working out the integral all the way to an answer. What I'm interested in is just setting up the limits. Now, setting up the limits, we work from the outside in, whereas in evaluating the integral we would work from the inside out. So we start with the outer variable, which is y. So what does y do? Now, on the outside, you're always going to have just numbers, that is constants, and these numbers will tell us the overall range of values for y. Now, the range of values of y we have to go through to capture the entire region is from 0 down here to 1 up here. In fact, I can put in those horizontal lines on the diagram. Y equals 0 and y equals 1. Y equals 1 in fact forms part of the boundary of the triangle. Y equals 0 only just touches the triangle in the corner. But these are the horizontal lines that grip this region vice-like. Okay, so I put the 0 and the 1 as the limits for y on the outside. Now, imagine the solid built above this. We've got this function x squared plus 5y squared x. Its graph will be z equals x squared plus 5y squared x, and that will be something sitting above this region, and we're talking about the volume underneath that graph and above this triangle. Imagine that volume. So y going from 0 to 1, that's how we sweep through the whole solid. Now if we slice it along the way, stopping at a particular y value, now it doesn't matter exactly at what level I draw this, let's say we stop at this y level, then that slice of the solid is the bit above this line on the base, on the region of integration. And what we need to know is what x is here where we enter the region, and what x is here when we leave the region, and those will be the lower and upper limits for the variable x that we want to put here and here. So this is really a case just of taking the boundary well, lines in this case, curves in general, of the region, and writing them in the appropriate form. Now, this left-hand boundary is x equals 0, it's the y-axis, so that gives us our lower limit for x, and this right-hand boundary, the one we cross when we when we pass the highest value of x before we leave the region, well, that diagonal line is, let's be careful about this. Now, we've gone 1 up and 2 across, so this is actually x equals 2y, and note the point 2, 1 on it, and 0, 0 both satisfy that equation. So we see that because this region isn't a rectangle, the upper limit isn't constant. In particular, although the largest overall x value is 2, the upper limit isn't 2. That would give the rectangle as the region of integration. We always start at 0, but we don't always finish at 2. Only at the top does x go all the way from 0 to 2. In general, it goes from 0 to whatever 2y happens to be at that y level. So there we have it, the upper limit is 2y.